to another episode of the Redbelly Insights podcast. This is episode 2. I'm your host, Mark Montfort from Not Centralized, and also the Australian DeFi Association, a great community of people working in this space. I'm proud to be joined in this episode by Vincent Gramoli, one of the founders of Redbelly Network. Vincent, how's it going?
Great. Thank you for having me, Mark.
Mate, this is really cool because we did a podcast with you, but you were hosted by Arturo, and that was down at Sydney, near the Opera House. We had the Opera House in the background. That was last year, and I think it was probably during winter as well. So it's nice to actually get to speak to you, being on camera rather than being behind the scenes, and having Arturo there. But Arturo was in episode 1. He spoke with Tim. Did you get to check out that episode?
Yeah, that was very insightful. Yeah, no, that was great. I think they did very well.
I think so too. There was a lot of pragmatic kind of lessons there that maybe people, whether they're in TradFi or blockchain, just needed to hear because they maybe weren't aware that, okay, if you're a degen, that blockchain will take a little bit of time. If it's done in the right way, it'll be better. But like, there's some practicalities when it comes to actually getting blockchain working in these spaces. But very important that we do this because these are just much better rails. So some really insightful stuff from that. They mentioned things like the importance of legal and financial frameworks and the barriers that institutional players still require. And they spoke about something that's near and dear to your heart, which is the finality and why that matters, about instant settlement as an essential piece for institutions. So, all of that kind of stuff was there in episode 2. We're going to dive into some more details in this episode here. But just by way of background, if there's anything that, people may have just been discovering Redbelly for the first time, I know it's a surprise, but it still happens. Can you give us a bit of a background as to your research? Because being an academic, there's a lot of great work you did at University of Sydney and still continue to do so. But can you give us a brief bit of background as to what led to your discoveries and to Redbelly Network?
Yeah, sure. And that's an interesting question. But Redbelly essentially is yeah, as you said, is something that some technology that came out of long effort on research, right? Blockchain research, and I would say that it's a characteristic of Redbelly, right? So we started working on the consensus back in 2016, doing the experiments back in 2017, showing that it was scaling pretty well, like the performance were going up as we were increasing the size of the system. But we commercialized much later, 2021, and I think what is typical from Redbelly is that we spend a lot of time doing the research before commercializing. Well, we could see that other blockchain companies would be commercialized before doing the research, raising fund first, and then hiring researchers. So the ones that are in good financial positions now are trying to catch up with the research as well because it's so important. And what you realize by doing that is that blockchain is extremely complicated. You might think it's just a piece of software, but it encompasses game theory, economics, cryptography, distributed computing, solving consensus problems. So it's really a difficult thing, and there's no better way but to collaborate with others in order to progress on that. And research is a very good way of solving these problems, interacting with people who are experts in their fields, because there is no single human, maybe except Satoshi Nakamoto, who can really master all these different arts.
No, absolutely. I think it's really interesting what you mentioned there, doing the research first before really diving into it. Whereas others, they're doing it after the fact. It's almost like the concept of measuring twice and cutting once, because you actually do it right the first time. And others are just going out there cutting as many things as they can, making all the mistakes, whether it's regulatory or whether it's consensus or whether it's community and all that kind of stuff. And then it's after the fact they're trying to tack on research. I do like the practical approach and pragmatic approach that Redbelly's done for this. And you do a lot of research, right? So speaking of that, the latest piece that you had, you looked into the dependability of blockchains and how they handle a variety of failures. Can you tell us a bit about that? And it's on the research page, folks, so that you can check it out. But just from directly from you, Vincent, because this is your work, can you tell us a little bit more about that?
Yeah, this is super fresh. Like this is a paper that has just been accepted for publication in the proceedings of the ACM International Middleware Conference that will be taking place in the US in December this year. So the way it works when you do research is that you submit your article, and then it's evaluated by your peers who are professors in other disciplines or specialized in sub-disciplines that are slightly different, but that are experts in the field where you submit. And then they try to assess, and it has been accepted for publication by these researchers, which means it will be presented and appear in the proceedings of the conference. What is interesting about this and what you've just said is that some of the companies were also trying to do things, and this has been super valuable for us as well, because it's a trial and error kind of thing, right? You try things, you realize that your blockchain is great for some type of applications. Back in 2019 we were talking CryptoKitties, 2021 NFTs. Now we're talking about real world asset, and by learning about what happened in the past, we know, and we start to know how to do better, right? And therefore we can prepare blockchain for high value assets, like things that will really matter to people, as opposed to more toy applications that are fun for the degen community. So I think there is an evolution. This fault tolerance work especially came because we looked at blockchain, as a spectator, trying to learn more how we can do better. And what was really striking was that, for example, Solana, for a year and a half between 2021 and 2023, was unusable for more than 154 hours, right? Cumulatively, there were multiple outages at different point in time. But if you translate that into service level agreement, you realize that it was offering an availability that was less than 2 nines, right? So usually that's the way you express a service level agreement on Amazon Web Services, for example, or on Google Cloud. I'm pretty sure most of the cloud services will offer at least 3 nines, which means they will be available 99.9% of the time, which is almost 100%, right? So we know that distributed system can offer a service most of the time. So why blockchain that is supposed to be fault tolerant cannot do as good? That was like the fundamental question we started to ask ourselves in order to start this project. And so we decided to just take a benchmark that we had, extend it. It's called Diablo, the benchmark. It was just here to test blockchains with realistic workload, Nasdaq kind of decentralized exchange workload, Uber mobility service workload, and so on and so forth. And we said, okay, why don't we use this benchmark that we open source, that is available out there, and we extend it by seeing how injecting failures impact the behavior of these blockchains, right? Because we deployed Solana, we deployed Avalanche, we deployed Algorand, we deployed DM, Redbelly, Ethereum. There were so many blockchains that we tested, right? So we thought, okay, let's do the same thing. Maybe we don't need to just stress test the blockchain. Let's send a constant sending rate and see how injecting isolated failures can impact the performance. And we came up with very big surprises. For example, we realized that there was cases with the warm-up of Solana that could lead to some late calculation of some metrics, and this late calculation could crash a node. And because all the nodes were executing the same code, then it could lead to a global crash. And then we talked to the Solana developers. We realized that this warm-up was not, thankfully, deployed on the mainnet, and that was just the default configuration on the source code. So we started learning that, oh my God, that's a good thing that the warm-up is not used on production, and this is also valuable for people who want to deploy Solana and test it, because otherwise their system would crash. We found out that Avalanche was using a throttling that could be also impactful to the performance, simply because if at some point the nodes were overloaded in terms of CPU consumption. They would start dropping messages. The consensus would not receive the necessary messages, and the throughput will become hectic. We made a lot of different discoveries about Aptos and the way it offload the leader, but tends to ask the validators to do more work, and therefore needs a lot of resources. And we also noticed that there were other issues in performances with Algorand as well in some cases. So we tested under partitioned injection of transient crash failures. We also tested really isolated failures where we lost packets voluntarily. So we did all sorts of different failure patterns to observe the variation of performance. That's what led to this very interesting paper.
No, fantastic. There's a lot of really interesting insights that you had from that. I mean, first and foremost, you talked about like the trial and error kind of work that was being done in the research first. And there's that saying that if we don't study history, as you mentioned before, looking at past values, we're doomed to repeat it. So it's very pragmatic as an approach that you guys do look at things that have gone wrong in the past, and more recent history, like when you spoke about Solana, and it's important that others need to know about this. The benchmarks thing is actually really interesting as well, because for folks like me, that do a lot of work not centralized in blockchain but also AI, benchmarks are massively important to really gauge the efficacy and how good a certain model or approach is. So I think it's really interesting that you raise that, because what you're talking about essentially, it encapsulates how do we have practical usage of blockchain. It's not just blockchain for the sake of it, but actually making it useful to solve real world business problems. Because like you said, the 3 nines is what's expected by normal businesses. We can't fail on that. And so I think it's important that blockchains do have this fault tolerance. But let's get into the tech side of things, the tech behind Redbelly. And the first question that we've got for you is that for those that are new to the network, what would you say, and you've kind of alluded to a little bit about this before, but what's the difference between Redbelly's architecture compared to other blockchains like the ones that you've just mentioned?
Yeah. So for those of those who are listening who are not used to Redbelly, I think I would summarize that there, let's say, the technological innovation at first that we had was around Superblock. So think about blockchain as a competitive process, right? You have everyone in the network trying to impose its block to the rest of the system. Why? Because if it wins, then its block will be appended at the next available index of the chain, and then the one that has imposed its block will get a reward, right, expressed in the cryptocurrency that is inherent to the blockchain protocol. So there is an incentive to win the lottery, right, or win the competition. The problem with this competition is that it prevents the system from really leveraging the resources. So you can add as many nodes as you want in a competitive blockchain system. At the end of the day, the number of blocks that will be appended at the next available index is 1, right? You can dissipate as much energy as you want. The performance will not increase, right? And that's a shame, right? Because you're not truly leveraging the resources, you're wasting the resources, but moreover, your performance will not go up as you scale the size of your system. Now, if you take a collaborative approach, which is what I refer to by the Superblock novelty of Redbelly, then suddenly what you have is that if you're lucky enough, you have different validators that are proposing disjoint blocks, right? Let's assume that each of the blocks are coming from different regions of the world, so they may contain disjoint sets of transactions. And if you have a consensus algorithm like DBFT we have in Redbelly, that will combine all these blocks together to agree not on a single block, but a super block, then you have suddenly a collaborative approach where you're truly leveraging the resources that you have at each of these validators. So if you are bringing more validator nodes, then you will potentially increase the number of transactions you will have in this super block linearly with the number of validators that you have added, right? So this is true scalability. You increase the size of the system, and by leveraging the resources you have added to the system, you will increase the number of transactions you can commit per consensus instance. Therefore, unit of time. And that's how you achieve scalability, right? Increasing or preserving the performance as you increase the size of the system.
And I
So
think
that's the
that's
main thing I would say. And but of course, there are other novelties since then, and I'm happy to elaborate on that later.
No, absolutely. I think that's one of the main ones that you mentioned there. And it's a surprise to many because we're used to in the blockchain world, or even just any kind of system, where the more that you use a system, the more it starts to break down. It doesn't get stronger over time. It's more of a, and when you mentioned the blocks, it's like a zero sum game. It's like the one that can get to it first, and we just keep on like throwing more and more money at it. It doesn't actually make a system stronger. It just pushes
But
power, to
if I
those
can
that can
add to
afford it.
that,
Yeah.
I just want to be completely transparent here.
Mm.
It's true that scalability cannot be achieved to infinity, right? So there is a moment where you truly leverage the resources of the machines, but there is a moment where there's another resource that becomes limited, which is the bandwidth of the network. And at some point, usually the performance will plateau anyway. So thinking that there is infinite scalability, I think,
Mm.
is a bit utopic, to be honest.
Oh, absolutely. So that, we can scale linearly, but we have to take those practical aspects into effect. And, it's really interesting, the super block concept. I encourage people to dive into that more because it's what enables you guys to be able to provide this uniqueness to the blockchain space. But you mentioned fault tolerance at the start. Now, that's become such a critical benchmark for, well, I think it has become such a critical benchmark for blockchains today. Why would you say that is? Like, what's the reason you think that such a thing is important?
Yeah, for us that became interesting. We've talked about the chain spec resolve, like that we're listing Redbelly blockchain as one of the fastest blockchain in terms of max TPS among 50 different blockchain technologies. And then you start asking yourself, okay, if I have 600,000 transactions per second, maybe I should stop optimizing the performance and look at other dimensions, right? And for us, as I mentioned, since we learned that Solana had some outages, we thought, okay, there might be something to be done around fault tolerance. Like it's great in the base case scenario to achieve high performance, but what if we are not in the best case scenario? What if you're running in this dynamic network and you have suddenly, for some reason, validators who decide to unplug their machine, right? Or they experience a network outage. How would the blockchain service behave, right? It's not because you have a power outage in a region of India that your entire worldwide blockchain network should crash, right? This is not reasonable, especially distributed systems should be fault tolerant. So we thought, okay, let's try to play with that, and the way we thought about it was artificially we're going to inject failure and see how it behaves. And for us, that was very important because we could see that the blockchain protocols were maturing, but still they were not to the level of cloud services. We talk about Web3, where we're talking about democratization of the use of blockchains by users who are not tech savvy, right? But we cannot even offer a service that is available 99.9% of the time. So let's try to do better there, and this will enhance the usability of the blockchain technology.
Yeah, absolutely. And I think it's a really interesting point because people, whether they are tech savvy, I would say even the ones that they're non-tech savvy at all, they're the ones that would really be surprised that, hang on a second, I came into blockchain because it's supposed to be quite secure and the distribution is, my friend Vincent told me at uni that it's supposed to make it secure, but there's more of this nuance. It's not just because it's blockchain that immediately it becomes secure. And I think it's really great that you've pointed that out. So I think that's the kind of thing that we need to dig into, because if we don't do it ourselves, where is it going to be discovered? It's going to be discovered when it's actually used out there in the real world. And it would just be such a shame when it's for supply chain or it's for payments and national payments infrastructure using a blockchain that hasn't tested these things and it collapses. How far back that sets the industry is going to be really interesting. You highlighted some of the other fault tolerance study things at the start. So let's jump to something that I think is really interesting, which is fairness in blockchain. And it's one of the things that we looked at very early on as like a concept coming into this space 4 years ago. You've spoken a lot about fairness in blockchain. Now, what exactly do you mean by fairness in the context here?
Yeah, so fairness is really one of the most overloaded term that I've seen in research. So if you talk to someone in formal verification, he would have his own definition of fairness. If you talk to a distributed computer scientist, it will probably think about starvation freedom. If you talk to different people, they will come up with different definition. If you talk to a bank, they will have also their own definition of fairness. So I think I was invited to give a talk at this fairness workshop located with the Financial Crypto Conference in Japan, and that was in April. And so what I wanted to do is to try to show all the fairness problems that I could see in blockchains that are super hot topics and that the community should look into, because there is so much work to be done. And so I covered several definitions of fairness, but the most traditional definition of fairness, usually, or maybe for me, is censorship resistance. So if you want a system to be fair, it should not be possible for a particular user, because of his background, because of his ethnicity, because of the way he's located in the world, to not have access to the blockchain service, right? So it should be fair for everyone in the sense that it should be accessible for everyone, right? And it would be ideal if you can have a coalition of misbehaving participants who can censor one particular participant, right? So you can think about it as, if you were a coalition of different machines in the network, you could send a lot of requests in order to overload the server such that only your request will go through, and none of the requests coming from someone who is further away will go through, right? And therefore you will censor this user who is further away from a validator node. That would be unfair, right? So that's the first definition. Now, there are other definitions, one of which relates to financial transactions, where essentially you can have traders that are unfair regarding to other traders, right? So, for example, I know that someone is going to buy a lot of Bitcoin. Let's say Michael Saylor, for example, is going to buy, or he bought a lot of Bitcoin. So usually when he buys Bitcoin, he buys a lot, right? So he sends this transaction. And because I can see his transaction, I was lucky enough to receive it because I'm close to him. I'm based in the US. I have this validator node close to his laptop. I receive his transaction. Then what I can do is I can front run him, make a profit, and even back run him, which means that I'm buying the Bitcoin, I execute this transaction, I sell my Bitcoin right after, and I make a huge profit because he has bought a lot of Bitcoin in between. And this is unfair, right? I should not leverage this private information that gives me an unfair advantage over the other traders, right? And that's something that is illegal on Wall Street. Why is it happening every day on blockchain technologies, right? It should not. This is another definition of fairness. We can think about the one I've just mentioned, which relate to fault tolerance. Usually, there is someone who pays for a service, right? So when you use a cloud computing provider, then you pay for a service because you have this service level agreement that you will be provided to you, and you can complain if the cloud provider doesn't, satisfy its promises. And you can have maybe a commercial, like you can find like a commercial gesture from the service provider if they fail to honor their promises. But in blockchain technology, you pay a fee for your transaction and you have no guarantee about the service level agreement. Why is it so, right? As a user, I feel like it could be unfair, and the president of the United States back in January was launching a meme coin, and Solana at some point was not available. Like, it could be unfair for him not to be able to trade his meme coin, right? So there are a lot of different perspectives, and I think fairness can be seen across these different dimensions, but it's extremely important that we try to make blockchain fair across these different dimensions such that users will be happy to use this technology.
Absolutely. I think there's a lot of different definitions of fairness, and it's funny because, like you said, it depends. Are you a computer scientist? What's or a developer, a user, an investor, the bank? What's fair to them is it's definitely always going to take these things that are personal to that organization or individual into account. But we need to think about these things from all of those different angles of who the user is, but the different aspects, like, fairness to access, fairness to other areas there. But let's talk about why it matters, because For example, what happens when blockchains are unfair? In practical terms, let's talk about it from a user's and developer's perspective. You allude to some of those things, but let's dive into it more. What can you say to that?
Yeah, I think blockchain is here also to bring fairness to the people through its transparency property, right? So you can think about mobility service, right? The gig economy in general, like the mobility service might, or yeah, just take mobility service as an example. There might be a company that is more interested in its own profit, and therefore will penalize a service provider like a taxi driver based on some condition that gives reward to the company, right? And these systems can be opaque. And I think transparency is supposed to bring this level of fairness in the sense that users should be able to choose between this service, this particular mobility service offer, or this other mobility service offer, based on maybe the reward that it gives to its taxi drivers, or the margin that it makes, or the cost that it incurs on the users, right? And users should be able to have this information in order to choose in a fair way which service they prefer. So I think blockchain inherently is supposed to be fair. And what we're seeing here are obstacles that prevent, really this fairness to be happening. When we talk about maximum extractable value, that's becoming a big problem. Of course, there's part of the community that feel like, oh, it's fair because I got this information before the others, so I should be able to exploit it. Maybe I have this very good bandwidth. I'm paying my internet service provider to get this very fast access to this information, and therefore I want to be able to make a profit out of this information. But if you step back a little bit, I think there should be rules and safeguards that define how people should benefit from others. And this maximum extractable value, like these front-ending attacks that I was mentioning, which is a subset of example of maximum extractable value attacks, came as a surprise. Like, in some sense, you had these really good hackers or opportunistic traders who managed to implement these things, right? And there were a lot of people who were not maybe capable enough in order to extract this value, that were left on the side. So is it fair that you need to be really a good hacker in order to become an opportunistic trader, or should it be a service that is available to anyone? So I believe in the latter.
Yeah, I think it's interesting because blockchains themselves, they technically, whether blockchains or let's call them any service and product provider, they're the ones that have the power because they know how the system works, and hopefully they've tested things as much as you guys have. But just letting a system run and having a bit of a Wild West, that's what we've had with blockchain. The fact that you can do things that are illegal in many cases in the financial world, but yet are just able to be tolerated in a blockchain world, such as front running, it does make it a murky and non-friendly place for normal everyday businesses to come in. I mean, just given what Redbelly's done, one of the biggest concerns that the businesses have had from the ones that we've spoken to here in Australia and around the world early on in our blockchain journey was that how can we use something that is overly transparent, as in when you and I do a deal, I can see your wallet history, you can see mine. Maybe that's good for just peer-to-peer stuff, but for businesses showcasing margins, the fact that you guys take that into account and you have zero knowledge proofs that can obfuscate and keep commercial confidentiality, I think it just shows the thinking that's been done to make this like a really useful sort of thing. And just the penalization that we need to take that into account, because otherwise these things will just be unfair systems, and instead of recreating something better, we're just bringing over the unfair world that we have right now to to new technology. But just one thing that I just want to highlight before we go to the next question on fairness is, I think that what you're talking about here, people need to think about, where do they see these sorts of maximum extractable value in just everyday life? There's so many things that are just obfuscated. You don't know, why are you getting this ad? Well, because those guys are paying for more money. It's not that they're necessarily a better thing. People complain about the algorithms on Twitter and other kind of places only showing them certain things. It's become a bit of a pay-to-play market, and I think blockchain and what you guys are doing at Redbelly can definitely help there when applied. The final thing on fairness, and we'll get to some community type questions that we've been talking about. Redbelly, how do you guys enforce fairness at the protocol level? And is it about preventing censorship, or is it something deeper?
That's a good question. I would say it's something deeper because we've been working on things without labeling them as fairness necessarily, but for quite some time. So back in the 2021, when we published this paper about Redbelly blockchain at the Security and Privacy Conference, what we had was a proof that there was censorship resistance offered by Redbelly. And what we meant by that is, if you are a honest participant that is creating a transaction that is well formed, for example, you use your private key to sign your transaction as you're supposed to do, then your transaction will, and you send your transaction as part of the way the protocol requires it, then your transaction will be eventually committed based on some assumption, of course, that there is no denial of service attack that will last forever, right? So if the system is not overloaded at some point in time, then we can guarantee that eventually, and for long enough, eventually your transaction will be committed, right? So that was very important for us to have this censorship resistance, making sure that even if you have a coalition of misbehaving participants who want to censor you, they will not be able to do so unless they have infinite power and can denial of service the system forever, right? So that was a very important property that we proved theoretically, right? So that's why we reasoned theoretically with theorems and proofs just on the paper. So it might seem a little bit confusing for practical people, especially when we were making some assumptions. But we went further than that, especially practically since then. And we have also tackled the problem of fairness in terms of maximum extractable value mitigation. And the problem I was mentioning, which is front-running attacks, or combined with back-running attacks, it becomes sandwich attacks. We are mitigating the risk of having these attacks on Redbelly Network with some simple things. For example, there is no auction mechanism where users can bid on a higher transaction fee in order to front run others, right? There's no such thing in the Redbelly protocol, right? So it's less likely that you will be able to front run by just having a higher transaction fee attached to your transaction. That's one thing. Other things that we have been implementing, and you were talking about penalizing, we've been working on accountability. As early as 2019, we defined what was the accountable consensus protocol with some colleagues at National University of Singapore, and we integrated accountability in the core of the blockchain, right? So making sure that if people misbehave and they try to influence the outcome of the consensus, for example, in order to make a profit, then we will be able to detect them and penalize them, right? So at the end, they will lose more than they will win, and this will guarantee that they are incentivized to behave. So these are the couple of things that we have, or we already have integrated, or that are already on our roadmap for this year. But we went even further, and now we have protocols that are ordering transactions that are not concurrent, but making sure that someone cannot front run someone else if there is a supermajority, like a large group of the nodes of the blockchain network that agree to say that transaction 1 was received by them before transaction 2. If this is the case, and a large portion of the networks has seen transaction 1 before seeing transaction 2, then it's impossible that transaction 2 will be executed before transaction 1. And if you guarantee that, you're drastically reducing the type of attacks that are coming from validator nodes that are reordering their transactions, right? And finally, another thing that is built in is the collaborative reward. The collaborative reward says that for each superblock that is appended to the system, the reward will be distributed evenly across candidates, and it's going to be distributed evenly across governors, right? So you have this fair distribution of the reward for all the nodes that were active and contributed to the superblock. And this is in contrast with the traditional blockchains that will only reward one of the nodes and therefore incentivize the competition. So that's also something that is built in the protocol.
Yeah, I think it's brilliant. It's that collaboration and positive sum kind of games versus just negative sum, and forcing people to beat each other to to win. Essentially, I think it's a very unique thing. Blockchain provides a lot of these thinkings around incentives, and just let's bring it to the real world asset space, because Redbelly is very known for, and that's the work that we've been doing with you guys around real world asset tokenization. But connecting it back to that, why do you think that fairness is such a crucial foundation for bringing regulated assets on chain?
I think as soon as you talk about real world assets, you talk about high value assets, you talk about assets that people care about, you talk about mortgages, you talk about property title, like things they have, worked so hard for their entire life to own, right? We're no longer talking about crypto kitties anymore. We're no longer talking about low value or fun meme coins that we're trading, right? So in this particular scenario of real world assets, we really care about security, we really care about fairness, we really care about fault tolerance. So all these topics are extremely important. And while we could live with a blockchain that was doing best effort kind of things, like trying to, just allowing you to trade things, sometimes you would get disappointed because your transaction would not have succeeded, even though you saw it in the blockchain. It got reverted because there was another branch with more blocks or a heavier chain or longer chain on the other side of the planet, and then the transaction you thought would be committed has been reverted. All these things could happen as long as you were looking at low value assets. But what we're talking about when you talk about real world asset, we're talking about bonds, we're talking about stocks, we're talking about commodities that are really valuable, and that becomes a big deal, that processes are here in place to ensure this fairness, that users will get the same access to the resources as the others, right? This might seem simple, but you can extrapolate this idea to any digital services, right? So, for example, the reordering properties is so fundamental to fairness, right? You would like to be able to access things if you ask for it first before others, right? And that makes a lot of sense, right? That's why people are not fighting where they pay their groceries, right? Because they go in line, and that's the way it works. That's natural, right? The one that come first, will be served first. And if you think about digital resources and you can digitalize the access to these resources, then reordering becomes a huge problem. So it goes even beyond finance, right? It's just access to resources in general.
Yeah, I think that can you and you said this before, but like where people that are coming into blockchain, I think one of the biggest self discoveries is that, oh, hang on a second, you can pay for something and not receive it. Whether it's the first time you get hit with gas fees that didn't put your transaction through on Ethereum, or something else that you're doing in the space and you've paid a large amount but don't guarantee to receive it. Now, in a competitive world like it was designed for, maybe that was okay early on with the early adopters, but when the mainstream is coming through and we're seeing that sort of thing change, the community evolves and more people, it's what we want. We want it to be different, but we also want adoption in the blockchain space, because like we want blockchains to be running the financial markets, the financial, like commerce in general. We have to build with this sort of fairness in mind, because if we don't, we'll just be turned away from. So just continuing on with the fairness thing and around like real world assets there. Another thing that we need to think about is that, well, fairness and fault tolerance, they influence compliance, risk, trust. How do you think that these things influence in institutional grade use cases, just like you've mentioned?
Yeah, I think it's exactly the point that you've mentioned. It's like if you want to lower the barrier of adoption, you need to make sure the mass will start using it. And the mass are not tech savvy, right? They have observed the world, how it works. They have defined their own notion of fairness, right? And if in order for them to trust a new system like that, they should not, need to understand the way the things are implemented, right? So we're not talking about tech savvy people or hackers anymore. We're talking about the mass, and they're not supposed to understand really all the ramification of the protocol and how they can exploit these corner cases and so on. It should look as a fair system for them, right? If for them to trust that this system works and will provide a good service to them. So it's extremely important. Now, I think compliance should come as a safeguard, and these people are used to government services, right? They are fair in some way. They are offering some level of fairness. And if not, then there is the government usually that is here to say, okay, it's going too far. There is risk representation maybe for the users, and therefore this is illegal, and you should correct your advertising or marketing campaign that goes too far and is selling lies, right? So there are guidelines that make sure that the services will honor their promises, that the users will find what they want, will get what they expect, and with blockchain, it's not the case yet. So we need regulation that improves, and I think it's going in the right direction at times, uh, but uh, but I think it's also important that government talk to academics, researchers, and industry players in order to better understand how these things work and how we can make sure that the users will get what they expect and will not be deceived, because the data gets deceived and they will stop using the service.
Absolutely think that that's right. Like there needs to be also something that we as the blockchain industry do before it is enforced onto us, with more restrictive rules, especially if you think about governments everywhere. As much as they try to do their best to understand the tech, they will always be behind because we move much faster in the tech space and in innovation than governments can ever keep up with. So if you think from that perspective, unless we do something and it's going to come from the top down, it is inherently going to be more restrictive than it could possibly be if we were to develop things ourselves, like what you guys are doing with this technology. So I think for people that are watching online on the live stream or the replay, you really need to think about that this is an activity that Redbelly is doing that is making it better for the industry by the industry, right? So just one last final thing before we get to community questions, and just on fairness and real world assets. In terms of the use cases, so thinking about things like, let's say, carbon credits or construction finance, right? Are there specific use cases like that where you think fairness is vital?
Yeah, so I think in all use cases, fairness is vital. As soon as you touch the real world assets, there is no use case I can think of where fairness will not be important, in one of the definitions that we have given. Yeah, so I was saying about securities, like you invest in company shares. Just think about it, like Redbelly has been partnering, and we've been working with Liquidize, for example, who tokenize private company shares. The same problem happens, right? You want to get the shares at the price that they're currently have, right? So you don't want to pay more. And if you don't have this front-running mitigation strategy, then someone could see your transaction where you're buying these shares and may say, "Oh, he might know something I don't know, and therefore I should buy before him and maybe sell it to him later on once I'll make in order to make a profit." And this is unfair, right? So it applies to securities, of course, because it's very similar to what we would say cryptocurrencies, for example, right? It includes cryptocurrencies, but or tokens at times, but if you think about property titles, same thing, right? You go to an auction in Australia. There are a lot of auctions in the housing market, and what people do is that they raise their hand, right? If you didn't raise your hand first, then you will not get the auction, right? And that's kind of fair, right? You have to be here. You have to have the money to buy this. I mean, or probably some unfairness topic we could go into about the housing market in Australia, in particular in Sydney. But you're here, you're buying a product before someone else, therefore you can acquire it, right? So that makes a lot of sense, and I think this is true for anything that is in the real world, anything that exists, whether it's a commodity, a security, or it has to be protected with some guidelines that make sure that fairness is there, because otherwise, again, people will not use this technology.
No, absolutely. I can just imagine, like, I go, my colleagues Arturo, who you guys have spoken to and met, and I can go get a coffee, for $5, and then when I come back up, I go, here you go, that'll be $5.50. that sort of front running and that sort of like access. There are some times where, I don't know, maybe I might think that that's fair, but if the system and the way that the world works doesn't think that that's fair, at least we have blockchain that can put things in place. It can enforce. We don't have to wait until we go to court or anything like that. We've got smart contracts that can really provide that. So really interesting kind of topic on fairness, and I'm sure that we'll dive deeper into it, as well as the papers that you've got. But let's get to some community questions. And this is an opportunity here to go into things that the community's been asking. We have an AMA session as well that we've done on Discord recently with Buffy, one of the community ambassadors there, and we went through this with Tim. But Vincent, there were some questions directly for you from the stuff that we've been collecting so far. So I'll ask you this one. Can Vincent share if in his years of experience in crypto, he's had discussions, shared ideas, or work with other high-level blockchain creators such as Vitalik Buterin and other blockchain founders and people at this level? What do you have to say?
Yeah, I've worked with some founders, not all of them. I didn't work with Vitalik Buterin. I mean, he read some of our papers on the balance attack. I remember he was acknowledging that there was some synchrony assumption in Ethereum when I read the paper. That was on a Reddit post. We didn't work together. I mean, my student went to the same conference, the Ethereum developer community conference that was back in 2019, where he presented. My student presented another attack against proof of authority in Geth and Parity. That was the attack of the clones. So it's not like they were working together, but they were going to the same conference presenting their ideas. I've been personally involved. I've been to different places. MIT, where Silvio Micheli is from. I invited him to Sydney, where he presented Algorand at the University of Sydney. I've been discussing with different people, about research, and I keep doing that. So I'm in collaboration with the head of research at Enza. I'm trying to see if we could give a talk there in order to present the latest finding we had on Solana, because they are really interested in improving the consensus protocol of Solana. And the findings that we had around the fault tolerance are insightful as well for them. So yeah, we keep discussing in different ways, social media, or we go to conferences. This is what researchers would do, but it's true that you don't find the founders at scientific conferences necessarily, right? So you might have to go to some very big business event, and then it's hard to pick their brain because they're busy with business tasks. But when I was in Japan, we were talking about financial cryptography. This is a fundamental concept of blockchain right now, how you can use blockchain in the financial space, trying to mitigate MEV attacks, for example. These were central problems that were there, or improving the performance of the blockchain even further. And the people I was talking to are usually researchers that are working in these disciplines. They are not the founders necessarily, but they're really making progress and trying to improve these protocols.
Yeah, I think it's really interesting that, and it's a good question for here in Australia, because people see us as being so far removed, and yet we do have people that either you like yourself that go and travel. There are conferences that bring some of these like crypto, sort of celebrities here. We've even had like Glenn Whale, who's the pioneer of quadratic research that does work with Vitalik. He's been to conferences here, as well as Audrey Tang. She was the first digital minister of Taiwan. So really interesting people. So I think we'll see more of that. Now, you mentioned, another thing that was mentioned was that Jack, overseas as part of the team, he spoke about how verifiable credentials would be the big product launch. Can you explain a bit more about this and what you envision this will look like for end users?
Yeah, verifiable credential is central to this accountability mechanism. You want to make sure that even though you don't know who they are, you should be able to prevent someone from replicating an attacks or a misbehavior, right? So you need some kind of accountability, and if you cannot really distinguish which addresses or public key belongs to the same user, then it becomes tricky, right? Verifiable credential for us is a way to give access to decentralize application services to particular users based on their credentials. So it could be like, I'm an adult, therefore I'm entitled to access the Redbelly network. It could be as simple as this, right? But it could be a bit more complicated, like I'm a sophisticated investor and therefore I should access this complex financial service that sits on top of Redbelly network. It could go far beyond that. It could be, I have a university degree and therefore I'm entitled to apply to this particular job because this is a requirement of the job description. And I can work with children, and therefore I can access this particular application that requires it, right? So it goes way beyond finance. So these verifiable credentials, but it's essentially, it should be the minimal amount of information you have to share with some service in order to get access to it, right? And so that's why also you've been talking about zero knowledge proof, which is central to that, right? You don't want to share more than the fact that you're an adult. You don't want to share your date of birth, right? You just want to say, yeah, I'm an adult. I don't want to tell you my age even, right? So zero knowledge proof allows you to give the proof without giving the knowledge that is not necessary. So it's a very useful tool that is also built in the way we reveal verifiable credentials. In terms of how would it looks like for the user, I think it's very important that we have self-custody of personal identifiable information. So these verifiable credentials should sit with the users themselves on a mobile device, maybe in their wallet, right? They keep ownership of this verifiable credential and they just share the bits and pieces that are needed in order for them to access services, right? They don't share their entire verifiable credential, of course, especially if it has a lot of information like a passport number, right? Most of the case, you don't need to share this. You just share the fact that you're a citizen of a particular jurisdiction, and that's good enough, or even a group of jurisdiction, and that's usually good enough. So self-custody is extremely important. Sitting in your wallet, making sure that you can access these services seamlessly, so that it should be simple for the user. And that's what we're working on at Redbelly, making sure that this experience flows very well, and it preserves this privacy as well.
Yeah, I find it interesting that there's a lot of governments around the world and even Australia that is starting to look into how do we look at digital IDs. And some mentioned decentralized technologies, which is great. And some even mentioned selective disclosure. So hopefully, wherever it is applied, that Redbelly gets a hand in being able to help with that, but B, that they at least use the right kind of technology, because without that, we just see censorship, repeats of technology issues that we've had in the past and more. And it even helps AI. Like, people don't realize that blockchain can help AI far more. And ZKPs can be part of that, and we'll dive into that in a future episode. But another question here was around the leadership, and what is your top priority for 2025 or the rest of 2025? I can't believe we're already nearly halfway through. But what would you say from your perspective is the top priority for the leadership team of Redbelly?
So yeah, we are more and more this. So things I didn't mention is that Redbelly is inherently decentralized in the sense that we don't even use a leader-based consensus protocol, and that's how Redbelly was performing so well when we inject failures. There is no single node that plays a particular role. Therefore, even if you attack a single node, it will not impact the entire system, right? Because we don't have a leader, as opposed to other technologies that are leader-based, especially in their consensus. But we're always trying to get more and more decentralized, right? So that's a big piece of work that we're working on, making sure that we have node operators that will contribute not just to be a candidate, which means they're here ready to be governors, but really involving the external node operators wherever they come from to be governors, to decide upon new things that's going to happen to the protocol, that may vote for new versions of the protocol. So we are working actively on trying to make sure that we will have improvement proposals that will be shared with the community, that will be decided by the community, and that will be implemented also by external developers, not necessarily just Redbelly Network. And we really want to achieve that. It's going to take a bit of time to get to the ideal decentralization. I think there is no perfect decentralized system yet, where like every company is working on that. Ethereum has been experimenting with proof of work. Now they are proof of stake. Now they are thinking maybe we should improve the performance with using risk instructions, or they always have improvement in order to get there, because if you're decentralized, you may not get good performances and so on. I think we're really on this trajectory. We have great ideas that we need to implement, but in the shorter time frame, I think we want also to make some improvements around the accountability. So right now we have some systems we can monitor things, but not all the penalization is being automated. So if you have misbehavior, then it may take time to penalize a misbehaving participant. Our ultimate goal is to have this completely automated in the system, but it requires a bit of effort. This is short-term accountability, full accountability, but longer term is like improving decentralization.
Fantastic. The final community question before we wrap up here, there was a question about, will there be any more nodes opening soon? Can you tell us anything more about that?
Yes, so we rely on node operators. If they're not there, Redbelly doesn't run, right? So it's as simple as that. We are already decentralized, right? So we need these node operators. We have a program to onboard the node operators in different phases. We have node operators currently running. They come from different jurisdictions. There are 200 node operators we critically need all the time running. So we're monitoring also their activity. We're giving them feedback if they are not active. We have learned a lot with them because they allowed us to understand whether the system was performing, whether there was a risk that the system could slow down, based on the activity of all these nodes. So we learned as well how node operators can, how often they're online, for example, that informs us what we should do in order to make sure that there is, 100% availability, ideally. We have several tranches of node operators. The first 200 have been helping a lot so far, but our aim is to scale, right? So we don't have enough node operators to scale to this level of decentralization that I was talking about. That's gonna come up next. And therefore, we're going to invite more node operators to join the testnet first. We're going to do some scalability tests, like really hundreds and hundreds of nodes, seeing how it behaves, if everything is flowing very well, and before moving them to production, right? So there will be phases where we will invite more node operators to join testnet, and we're talking about hundreds and hundreds of them. And then once we will be convinced that it works well, we will progressively move them to production. But be patient, it takes time, and we didn't define when this large batch of node operators will be coming to testnet. That's still being discussed at the moment, based also on our progress internally, making sure that it will not break anything that we have implemented so far.
Yeah, I think that people don't realize just how much work and effort is going on in the engineering sense. Like we see Tim running around and doing a lot of the with Alan and the rest of the crew, and marketing and sales, and getting partners onboarded, and discussing things, because things don't happen without actually sharing and talking, and showcasing what it is that is possible there. So it's all a part of that. But the engineering, I think, is like a massive aspect of all of this that sits behind the scenes here. And so in time, we'll be able to do that so that we can scale. So just to recap, we spoke about the research that you've got around fault tolerance. And, it was quite striking to me. I've read the paper, but again, just hearing it, 154 hours cumulatively, that a system that can be so relied upon can be down. Like, it needs to be looked into more. We spoke about fairness, the concept of the super block, and collaboratively coming together to bring that about, and how you need this if we're really going to onboard real world businesses and use cases. And then obviously some of the community questions, we've got a long list of all the other ones, and we'll answer that over time, whether in the community AMAs, as well as other mechanisms that we can get yourself and the team to answer. But Vincent, as we round out, what's the best way for people to follow your research? Obviously, we'll point them towards Redbelly and the research section on Redbelly. But what are some other things? What are other ways that people can find your research and insights?
Yeah, so you can follow me on X, Vincent Gramoli, attached. That's one way. I would say go to the research tab on the website. So you will find research. There's the white paper, there's the yellow paper, but there's a lot of research papers that have been published in peer-reviewed scientific conferences and journals. In general, I would post about the upcoming research that relates to Redbelly, and so that people are aware. You can go on Instagram, Vincent Gramoli. I'm not as present on Instagram. I tend to be overwhelmed by the quantity of messages, so bear with me. And yeah, that's pretty much it. Our team is on Discord. If you want to ask questions, usually they're quite responsive. So let me know. And of course, we're really interested in hearing any feedback that you may have. As you were saying, Mark, we can see the business side of things when Tim and Anne are out there. I think we should do better in showing at Redbelly the improvement that we're doing to the software stack. I mean, it's so complex that even vulgarizing it takes a bit of time. So it's not just doing a sprint demo. It's a bit more than that. We need to explain the context and what it means for people to be able to consume it. But I think, yeah, we could communicate more on what we have achieved. Like, it's so big. When we step back and look at what we have achieved, like, we realize it's extremely complex, and I think we should be communicating more. So if you have any feedback on the type of format or anything, like, I'm talking to the community in general, feel free to share it on X or any social media where you can find me. And of course, send emails to info@redbelly.network if you need.
Absolutely. And I think exactly what you're describing there, this is the whole reason why we've got Redbelly Insights now as this weekly show, why we've started this AMA, and why people are going to see a lot more activity in the community, because it's being asked for. And I think it's not just like the activity of sales and marketing, but it's also the engineering side and what is it in it for developers. Because for folks like Arturo, one of the biggest reasons why we liked what you guys were doing, because it's being built in such a pragmatic way that it just, if you think about, if you're coming over from non-blockchain to blockchain, you need certain things in place. And Redbelly is one of the leaders in being able to provide that, if not the leader, I would say. So look, Vincent, so much insights there. People want to look at this, be able to watch the replay. Even, we'll do something around AI to help people understand all of this, because it's a great translator. But thank you so much for the hour, and we'll speak with you soon.
Thank you very much, Mark.